Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the intensity shifts. Initially, let me discuss about the two terms, chromophore and auxochrome. So, coming to the chromophore, chromophore can be defined as any group that shows characteristic absorption in the UV or visible region. So, chromophore means any group that shows characteristic absorption either in the UV region or in the visible region. Especially the compounds containing pi electrons are active in the UV region. That means they show characteristic absorption in the UV region, especially the compounds containing conjugated systems shows characteristic absorption in the UV region, especially due to pi to pi star transitions. So, the conjugated compounds shows characteristic absorption in the UV region due to pi to pi star transition. On the other hand, the compounds containing unsaturation along with heteroatom. So, heteroatom means it consists of non-bonding electrons. So, n electrons will be present. That means such compounds will show characteristic absorption in the UV region due to pi to pi star transition and also due to n to pi star transition. So, whenever an unsaturated compound is present along with the heteroatom, they shows characteristic absorption in the UV region mainly due to pi to pi star transition and also due to n to pi star transition. So let us consider two examples, especially when we consider 1,3-butadiene. So 1,3-butadiene. So its structural formula is CH2 double bond CH single bond CH double bond CH2. So here the conjugated system is present and hence it shows characteristic absorption in the UV region and the lambda maximum is absorbed. So lambda max is observed at 217 nanometers. In the similar way, if we consider acetaldehyde, its formula is CH3C double bond OH. So, oxygen contains lone pair of electrons. Already pi electrons are present. So, this compound shows characteristic absorption in the UV region, especially due to N2 pi star transition, and hence the lambda max is observed at 280 nanometers. So, especially the conjugated systems and also unsaturated compounds with heteroatoms will show characteristic absorption in the UV region and hence these compounds can be considered as chromophores. So, that means especially the doubly bonded compounds or the compounds containing triple bond will show characteristic absorption in the UV region and hence they can be considered as chromophores. So on the other hand, coming to the auxochrome. Auxochrome means it will not show any characteristic absorption in the UV region. But whenever these groups are present on the chromophores, then the characteristic absorption will be shifted to longer wavelength region. So initially let us consider what type of groups can be considered as auxochromes. Auxochromes means OH, NH2, Cl, etc. Always, if you carefully observe these groups, they consist of lone pair of electrons. So let us consider one best example, that is benzene. So no doubt at all, benzene is a chromophore and it shows characteristic absorption at 255 nanometers. But whenever OH group or NH2 group or Cl group is present on the benzene, let us see what happens. Let us suppose that NH2 group is present on the benzene. Then what happens? Here the nitrogen of the NH2 group contains lone pair of electrons and these lone pairs are in conjugation with the benzene nucleus. With the result, this NH2 group is responsible for the extension of conjugation and hence the lambda max is shifted to longer wavelength region and it is observed at 280 nanometers. So undoubtedly the presence of auxochrome will shift lambda max towards longer wavelength region. And remember that these groups will not show any characteristic absorption in the UV region. But when they are present on the auxochrome, that means when they are present on the chromophore, the absorption maximum will be shifted to longer wavelength region. Okay, is it clear about the chromophore and auxochrome? Then we will discuss about the intensity shifts. Coming to the intensity shifts, to have better understanding about the intensity shifts, always a graph should be drawn between wavelength and intensity. So it is the lambda max of the benzene nucleus. So initially what is the value of lambda max for the benzene nucleus? That is 255 nanometers. And similarly, if we consider aniline, lambda max is observed at 280 nanometers. So when we consider the structure, it is the structure of the benzene and aniline means here NH2 group is introduced. So here whenever the lambda max is shifted to longer wavelength region, it is called as bathochromic shift. So it is good example for bathochromic shift. So bathochromic shift means shift towards the longer wavelength region and this bathochromic shift is also known as red shift. On the other hand, if we consider aniline in the presence of acidic solution, that means aniline is protonated and hence initially if we consider aniline, lone pair of electrons will be present on the aniline and hence it is responsible for the extension of conjugation, and hence lambda max is shifted to longer wavelength region. But whenever if we consider aniline in acidic media, that means aniline will be protonated and lone pair of electrons are not available. And because of the steric hindrance, always lambda max for protonated aniline is observed at 203 nanometers. That means the lambda max is shifted to shorter wavelength region and hence it is called as hypsochromic shift. In other words, it is also called as blue shift. So the shift towards shorter wavelength region is called as the hypsochromic shift. So bathochromic and hypsochromic shifts are concerned with the wavelength. On the other hand, we are having shift with respect to the intensity and they can be called as hyperchromic shift or hypochromic shift. So hyperchromic shift means it is a shift towards the high intensity region. So this is called as hyperchromic shift. So hyperchromic shift means shift towards the higher intensity region. So on the other hand, if it is shifted to low intensity region, then that is called as hypochromic shift. So hyper and hypochromic shifts are totally related to the intensity. So if the intensity of the absorption is increased, then that is called as hyperchromic shift. If the intensity of the absorption is decreased, then that is called as hypochromic shift. And coming to the examples, especially when we consider pyridine, the intensity of the absorption is observed at 3750 when it is substituted with methyl group at second position, and the normal pyridine will show absorption at 2650. So definitely there is increase in the intensity and hence it is good example for hyperchromic shift. On the other hand, if we consider biphenyl, initially it shows intensity around 19,000, but whenever if we consider 2-methyl biphenyl, then the intensity of the absorption will be decreased to 10,700. So there is some decrease in the intensity of the absorption and hence it is good example for hypochromic shift. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.